Tonight, we're going to take a journey that quietly reshapes how you see everything. Not through shock or spectacle, but through scale. A scale so vast that the mind struggles to hold on to it. We're going to explore our home galaxy, the Milky Way, and discover where it truly sits in the hierarchy of the universe. Because what most people don't realize is this: the Milky Way is both enormous and almost nothing at the same time. At first glance, the Milky Way feels immense. It stretches roughly 100,000 light-years from one edge to the other. Light, traveling at nearly 300,000 kilometers per second, needs 100,000 years just to cross it. Inside this vast spiral are somewhere between 100 billion and 400 billion stars. Astronomers can't give an exact number, because counting stars from inside a galaxy is like trying to count every tree in a forest while standing deep among them. Some are visible. Many are hidden, obscured by dust, distance, and overlapping light. Our Sun is just one of these countless stars. It sits about 26,000 light-years from the galactic center, tucked into a modest spiral arm known as the Orion Spur. We don't live near the center. We don't occupy a privileged location. We live in the galactic suburbs, in a relatively calm region where stars are spaced far enough apart and catastrophic explosions are rare enough for life to survive long enough to ask questions like these. Every star you've ever seen with the naked eye belongs to this single structure. Every constellation, every planet visible in the night sky, every shooting star streaking overhead, all of it exists inside the Milky Way. For most of human history, people believed this was the entire universe. Everything that existed was contained within that faint, glowing band across the sky. And in a sense, it made sense to think that way. The Milky Way is not a small galaxy. In fact, it's one of the largest galaxies in the observable universe. Roughly 95% of all galaxies are smaller than it. Most galaxies are dwarfs, containing only a few million or a few billion stars. Compared to them, the Milky Way is a giant. By galactic standards, it sits comfortably in the top 5%. But here's where the perspective begins to shift. The Milky Way is not alone. It has neighbors. The nearest large one is Andromeda, about 2.5 million light-years away. Andromeda is even larger than the Milky Way, containing roughly 1 trillion stars. The two galaxies are slowly falling toward each other, destined to merge billions of years from now. It won't be a violent crash of stars colliding, but a slow gravitational dance where the structures dissolve and reform over cosmic time. Orbiting the Milky Way are smaller companions as well. The Large and Small Magellanic Clouds, visible from the southern hemisphere as hazy patches of light, contain billions of stars of their own. Along with dozens of faint dwarf galaxies, they form what astronomers call the local group. This is our immediate cosmic neighborhood, spanning about 10 million light-years. At this point, the Milky Way still feels important. It dominates its surroundings along with Andromeda. But zoom out just a little more, and that sense begins to fade. The local group is merely a tiny fragment of a much larger structure known as the Virgo supercluster. This vast collection contains hundreds of galaxy groups and clusters, including the massive Virgo cluster itself, home to thousands of galaxies, many far larger than our own. The Virgo supercluster stretches over 100 million light-years and contains roughly 100 trillion stars. If the Milky Way once felt like a city, here it becomes a single house. And even that metaphor is too generous. It's more like a single room. Yet even this is not the full picture. In 2014, astronomers discovered that the Virgo supercluster itself is only part of an even larger structure called Laniakea, a name meaning immeasurable heaven. Laniakea is a supercluster of superclusters, spanning more than 500 million light-years and containing around 100,000 galaxies. Everything within it, including the Milky Way, is slowly flowing toward a gravitational center known as the Great Attractor. Our galaxy is not stationary. It is drifting through space, carried along vast gravitational currents, falling toward concentrations of mass so enormous they dwarf our entire local neighborhood. If you shrank the Milky Way down to the size of a grain of sand, Laniakea would be the size of a large room around it. And still, we are nowhere near the largest scale. Beyond Laniakea lies the cosmic web. On the grandest scales, the universe is not a random scattering of galaxies. It resembles a vast network of filaments and walls, with galaxies tracing enormous threads that stretch across billions of light-years. Between these filaments lie immense voids, regions so empty that entire galaxy clusters are separated by distances measured in billions of light-years. The observable universe itself spans about 93 billion light-years. Within it are an estimated 2 trillion galaxies. 2 trillion. The Milky Way is just one of them, not particularly special, not particularly rare. If every galaxy were represented by a single grain of sand, you would need enough sand to fill multiple Olympic-sized swimming pools. The Milky Way would be one grain among countless others, indistinguishable without a label. And yet, even among galaxies, size varies dramatically. Some galaxies, like IC 1101, are monsters beyond imagination. IC 1101 stretches roughly 6 million light-years across, 60 times wider than the Milky Way, and contains around 100 trillion stars. Entire neighboring galaxies would sit comfortably inside its boundaries. But galaxies like this are exceptionally rare. They are the outliers, not the standard. Most galaxies are dwarfs. Tiny, faint collections of stars that barely register against the darkness of space. For every galaxy larger than the Milky Way, there are thousands that are smaller. This is the paradox. The Milky Way is both enormous and insignificant. It is a giant among galaxies, yet utterly dwarfed by the structures that contain it. Both statements are true, depending entirely on the scale you choose to look at. And as we continue to zoom outward, past galaxy clusters, past superclusters, past walls and filaments, we begin to approach structures so vast that they challenge the limits of our understanding. This is where the story truly begins to stretch the mind. As we keep pulling back, the Milky Way continues to lose its sense of importance. Not because it changes, but because the stage it sits on becomes unimaginably larger. To really understand where our galaxy stands, we need to look at the full spectrum of galaxies that exist. When people imagine galaxies, they often picture grand spirals like the Milky Way or Andromeda. But those are not typical. They're the exception. The universe is dominated by dwarf galaxies, small, faint systems that may contain only a few million stars and stretch just a few thousand light-years across. They are fragile, easily disrupted, and incredibly common. If you were to randomly select a galaxy anywhere in the universe, odds are overwhelming that it would be one of these dwarfs. Compared to them, the Milky Way is massive. Its disk alone is wider than many entire galaxies. Its dark matter halo extends far beyond its visible stars, giving it a gravitational reach that captures and controls dozens of smaller companions. This is why astronomers say the Milky Way is among the largest galaxies. Not because it competes with the absolute giants, but because it towers over the vast majority. Yet even within the category of large galaxies, there are those that push scale to its limits. Some spiral galaxies stretch 4, 5, even 6 times wider than the Milky Way. Others, like giant ellipticals, contain trillions of stars packed into enormous, featureless spheres. These galaxies didn't form quietly. They grew by consuming others, merging again and again over billions of years, becoming gravitational kings at the centers of galaxy clusters. In those environments, the Milky Way would be unremarkable. It would be just another medium-sized spiral, easily overshadowed by giants that dominate their surroundings. Our galaxy feels special largely because of where it lives, in a small, quiet group far from the crowded chaos of major clusters. That quietness matters. Galaxy clusters are violent places. Galaxies there pass close to one another, stripping gas and stars through gravitational tides. Hot, X-ray emitting gas fills the space between galaxies, robbing them of the raw material needed to form new stars. In such an environment, a galaxy like the Milky Way might have lost its gas long ago, aging into a red, lifeless system. Instead, our galaxy resides in relative isolation. It has retained its gas. It still forms new stars. Slowly, steadily, without dramatic bursts or catastrophic interruptions. That calm history may be one of the reasons planets like Earth had the time and stability needed for life to emerge. But calm does not mean static. The Milky Way is moving. Along with its neighbors, it is flowing through space at hundreds of kilometers per second, pulled by massive concentrations of matter far beyond our immediate view. This motion led astronomers to one of the most intriguing discoveries of modern cosmology, the Great Attractor. For decades, scientists noticed that our galaxy, and thousands of others nearby, were drifting in a specific direction, faster than cosmic expansion alone could explain. Something enormous was pulling us. Yet when astronomers looked in that direction, they saw very little. Dust and gas in the plane of the Milky Way obscured the view. Only by observing the universe in infrared, radio waves, and X-rays did the hidden structures reveal themselves. Massive galaxy clusters lay beyond the veil, containing enough mass to bend the motion of entire regions of space. And even those clusters were part of something larger still. This realization reinforced a crucial idea: galaxies do not exist in isolation. They are embedded in a vast cosmic web shaped primarily by dark matter. Dark matter forms the invisible scaffolding of the universe. Galaxies form where this scaffolding is densest, lighting it up like lanterns hanging on an otherwise unseen structure. The filaments of this web stretch for hundreds of millions, sometimes billions, of light years. Along them lie galaxy groups, clusters, and superclusters. Between them are voids, enormous regions where matter is scarce. Some voids are so large that light would take billions of years to cross them. One of the largest known voids spans nearly 2 billion light-years. Inside it, galaxies are few and far between. From its center, even massive galaxy clusters would appear as faint smudges at unimaginable distances. Compared to this emptiness, the Milky Way is not just small, it is negligible. And yet, even voids are only part of the story. Among the most astonishing discoveries in cosmology are the colossal walls of galaxies. These are immense sheets and filaments where thousands, sometimes millions, of galaxies align along vast structures. One such structure stretches more than 1 billion light-years across. Another, even larger, extends for several billion light-years. Then there is the largest known structure of all. An enormous galactic wall spanning roughly 10 billion light-years. To put that into perspective, light takes 100,000 years to cross the Milky Way. It takes 10 billion years to cross this single structure. That is most of the age of the universe itself. The existence of structures this large challenges our understanding of cosmic evolution. According to standard models, gravity simply shouldn't have had enough time to assemble matter on such scales. Yet there they are, stretching across the cosmos, forcing scientists to reconsider how structure forms and grows. Against this backdrop, the Milky Way is no longer a galaxy that feels large. It is a single dot on a filament, a microscopic feature in a pattern too vast to fully comprehend. And still, the scale continues. The observable universe, the portion of the universe whose light has had time to reach us, is about 93 billion light-years across. Within it are those 2 trillion galaxies, each containing millions to trillions of stars. The total number of stars is so large that it defies intuitive meaning. And this observable universe may be only a fraction of what exists. Beyond the cosmic horizon lies space we cannot see, not because it doesn't exist, but because light from there has not yet reached us. The universe may be far larger than we can ever observe. It may even be infinite. If that is the case, then the observable universe itself is insignificant compared to the totality. And the Milky Way, already small, becomes infinitesimally tiny, an almost meaningless fraction of an endless whole. Some theories go even further, suggesting that our universe might be just one of many. A multiverse, where countless universes exist side by side, each with its own physical laws and histories. These ideas remain speculative, but they arise naturally from serious attempts to understand cosmic inflation and quantum mechanics. If they are true, then our universe, already vast beyond imagination, is just a single bubble in an infinite foam. And the Milky Way is a microscopic detail within that bubble. At this point, it's natural to feel overwhelmed. Everything that once felt large now feels small. Everything that once felt central now feels peripheral. The Milky Way, our cosmic home, is not the center of anything. It is not special in position, size, or role. And yet, this realization is not empty or meaningless. Because within this tiny galaxy, on one small planet orbiting one ordinary star, something extraordinary happened. Matter became aware of itself. Atoms forged in ancient stars came together, forming life capable of asking where it came from and how big the universe really is. You are made of material that once existed in the hearts of stars. Those stars lived, died, and scattered their elements across space long before the Milky Way took its current shape. In that sense, you are older than the Sun, older than the Earth, and deeply connected to the vast structures that now dwarf our galaxy. The Milky Way may be small compared to the universe, but it is still our home. Every story humans have told about the night sky, every myth, every constellation, every moment of wonder begins here, under this spiral of stars. And the story isn't over. Billions of years from now, the Milky Way will merge with Andromeda. Their stars will mix, their shapes will dissolve, and a new galaxy will emerge, larger, redder, quieter. Long after that, star formation will fade. Galaxies will grow dark. The universe itself will continue expanding, stretching structures farther apart until the night sky grows empty. But right now, in this brief moment of cosmic time, we exist inside a galaxy that is both enormous and insignificant. A galaxy large enough to contain hundreds of billions of stars, yet small enough to be swallowed by them. Universe without a trace. That is the true scale of the Milky Way. When we widen the lens even further, the story of the Milky Way becomes less about size and more about timing. The universe is not just vast in space, it is vast in time. And the Milky Way occupies only a thin slice of that timeline. The universe is about 13.8 billion years old. The Milky Way, by contrast, began forming roughly 13.5 billion years ago, not as a single object, but as a collection of much smaller pieces. In the early universe, nothing looked like the graceful spiral we see today. There were no grand disks or sweeping arms. There were only small, chaotic clumps of gas and dark matter, merging again and again. These early building blocks were primitive. Their stars were massive, short-lived, and violent. They burned hot and fast, exploding as supernovae that seeded the surrounding space with heavier elements. Without those early generations of stars, there would be no carbon, no oxygen, no iron, and no planets like Earth. Every atom in your body heavier than hydrogen or helium was forged in stars that lived and died long before the Milky Way became what it is now. Over billions of years, these small protogalaxies merged. Their dark matter halos combined, their stars mixed, their gas settled into rotating disks. Slowly, structure emerged from chaos. The Milky Way grew layer by layer. Generation by generation, absorbing smaller galaxies that wandered too close. Some of their remnants are still visible today as stellar streams arcing across the galactic halo, ghostly traces of ancient galaxies long since consumed. Astronomers can read this history in the stars themselves. The chemical composition of a star acts like a fingerprint, revealing the environment in which it formed. By studying these chemical signatures, scientists have reconstructed the Milky Way's family tree. Our galaxy is not a single, unified object with one origin. It is a mosaic. A patchwork assembled from many ancestral galaxies that no longer exist as independent entities. This process of growth through mergers is not unique to the Milky Way. It is how all large galaxies form. The difference is scale and environment. Galaxies in dense clusters grew quickly and violently, consuming neighbors at a rapid pace. Galaxies like ours, in quieter regions, grew more slowly and steadily. That slower pace allowed disks to survive, spiral arms to persist, and stable planetary systems to emerge. Even today, the Milky Way is still growing, though at a much reduced rate. Small dwarf galaxies continue to fall in, stretched and torn apart by tidal forces. Their stars are added to the halo, their gas sometimes fueling new star formation. But the era of rapid growth is long past. The Milky Way has reached something like maturity. In cosmic terms, our galaxy is middle-aged. This raises an important question: if the Milky Way is neither especially large nor especially small, neither young nor ancient, neither chaotic nor extreme, what does that say about our place in the universe? It suggests that our existence is not tied to cosmic rarity in size or power, but to balance. The most extreme galaxies, those with intense starbursts or ravenous black holes, are spectacular, but hostile. They flood their surroundings with radiation. They destabilize planetary systems. They burn through their gas quickly and violently. Life, at least as we understand it, would struggle to survive in such environments for long. The Milky Way, by contrast, is calm. Its central black hole is quiet, feeding slowly. Its star formation rate is modest. Its spiral arms rotate gently, creating regions where stars and planets can form without being constantly sterilized by nearby explosions. This long-term stability may be rare in its own way, not in size, but in suitability. When we talk about the scale of the universe, we often focus on how small we are. But there is another perspective. The universe is large enough, and old enough, for systems like ours to exist. It has had time to cool, to organize, to create environments where complexity can arise. This brings us back to the question of life. With hundreds of billions of stars in the Milky Way alone, and trillions of galaxies beyond it, the number of planets is almost certainly enormous. Observations show that planets are common. Most stars host them. Many of those planets orbit in regions where liquid water could exist. On paper, the universe should be teeming with life. And yet, the sky is silent. This silence has troubled scientists for decades. If intelligent civilizations are common, where are they? Why don't we see evidence of their existence? Why hasn't the galaxy been reshaped by their activity? One possible answer lies in scale. The Milky Way is 100,000 light-years across. Even traveling at the speed of light, communication across the galaxy takes millennia. At realistic speeds, interstellar travel would take longer than civilizations might survive. Entire cultures could rise and fall before their signals ever reached another star system. Another possibility is timing. We may be early. The universe is still relatively young. Heavy elements are more abundant now than they were billions of years ago. And they will be even more abundant in the future. Civilizations may be rare now but more common later. Or they may be common now, but separated by such vast distances in space and time that they never overlap. Or perhaps intelligent life is fragile. Perhaps it tends to destroy itself before it spreads. Perhaps technological civilizations are brief flashes in cosmic time, easy to miss unless you are looking at exactly the right place at exactly the right moment. Whatever the answer, the scale of the universe ensures one thing: even if we are not alone, we may still feel alone. Now consider this: the observable universe is limited not by physical boundaries, but by time. There are regions of space whose light will never reach us, no matter how long we wait. Because the expansion of the universe is accelerating. Those regions are already receding faster than light relative to us, carried away by the stretching of space itself. This means that the universe we can ever observe is shrinking in a sense. More and more galaxies will eventually slip beyond our cosmic horizon, disappearing from view forever. Far in the future, distant galaxies will fade away, leaving only our local group visible against an otherwise empty sky. Civilizations that arise billions of years from now may see a much lonelier universe than we do today. They may have no evidence that other galaxies ever existed. The cosmic web itself will be hidden from them, erased by expansion. In that future, the Milky Way, or what remains of it after merging with Andromeda, will seem like the entire universe. A single island of stars in endless darkness. And perhaps that has already happened elsewhere. Perhaps there are civilizations in distant regions of space that once shared a universe rich with galaxies, but now find themselves isolated, unaware of the true scale that once existed. This thought brings us back to the present moment. We live at a time when the universe is still visible. When galaxies fill the sky. When the cosmic web can still be mapped. When the story of structure, from the smallest scales to the largest, can still be reconstructed. The Milky Way is small compared to the universe. But it exists at a moment when understanding is possible. That may be its greatest significance. When we speak about scale, it is easy to fall into despair. To look at the Milky Way shrinking into nothing against the backdrop of the universe and conclude that nothing matters. But that reaction comes from a misunderstanding of meaning itself. Meaning does not come from size. It comes from context, from experience, from awareness. A single thought occupies no space at all, yet it can change the course of a life. A single moment can define decades. In the same way, a single planet in a small galaxy can carry significance that no cosmic structure, no matter how vast, can replicate. The universe does not assign importance by mass or distance. It simply unfolds according to physical laws. Meaning arises only when something within the universe becomes capable of noticing it. And that is where the Milky Way changes from being insignificant to being profound. Because somewhere within this galaxy, matter has crossed a threshold. It has become capable of reflection. The atoms forged in ancient stars have arranged themselves into minds that can measure the universe, question its origins, and wonder about their own place inside it. The universe, in a very real sense, has become aware of itself. This awareness is not evenly distributed. Most of the universe is dark, cold, and silent. Vast regions contain nothing but thin gas and drifting particles. Even among stars, life may be rare. Even among life, intelligence may be rarer still. And among intelligent beings, the ability to grasp cosmic scale may be vanishingly uncommon. From that perspective, consciousness is not small. It is extraordinary. The Milky Way may be one galaxy among trillions, but it is one of the places where the universe thinks. This reframes the question entirely. Instead of asking why we are so small, we can ask why anything exists that can recognize smallness at all. Instead of focusing on insignificance, we can focus on improbability. The universe is vast enough that complexity can emerge, and stable enough that it can persist long enough to understand itself. Scale, then, is not an argument against meaning. It is the condition that allows meaning to exist. Consider time again. Human lives last decades. Civilizations last centuries. Even the longest-lived cultures vanish in a blink compared to galactic timescales. The Milky Way will exist for trillions of years. The universe itself may last far longer. And yet, the fact that our lives are brief does not strip them of value. In fact, brevity is often what gives experiences their intensity. A sunset is meaningful precisely because it ends. A life is meaningful because it is finite. The same applies on cosmic scales. The current era of the universe, rich in stars, heavy elements, and visible structure, is temporary. One day, star formation will cease. Galaxies will fade. The universe will become darker, colder, and simpler. We live during a brief window when complexity is possible. In that sense, we are not late or early. We are precisely on time. The Milky Way is part of that window. It is not the largest galaxy, nor the smallest. It is not the oldest, nor the youngest. It exists in a balance point where chaos has settled enough for order to arise, but not so much that everything has gone quiet. That balance may be far rarer than size or power. When people imagine significance, they often imagine being central, dominant, or permanent. But the universe suggests a different model. Significance arises from participation, not dominance. From interaction, not control. From observation, not ownership. We do not need to be at the center of the universe for our existence to matter. There may be no center at all. The universe does not revolve around anything. It expands everywhere at once. Every point can be considered a center, depending on how you look at it. From our perspective, the observable universe expands away from us. From another galaxy, it expands away from them. There is no privileged location. This removes a burden we didn't realize we were carrying. We do not need to justify our existence by cosmic importance. The universe does not demand that we be large or eternal. It simply allows us to be. And in that allowance lies freedom. The Milky Way does not exist to host life. Life exists because conditions allowed it. And once life exists, it creates its own meanings, values, and purposes. These are not written into the fabric of space-time. They are written into experience. When you look at the night sky and see the faint band of the Milky Way, you are not seeing a symbol of insignificance. You are seeing the environment that made thought possible. You are seeing the accumulated history of billions of years of star formation, chemical evolution, and cosmic chance. That thin streak of light contains every human story that has ever been told. Every fear, every hope, every love, every idea. Not because the galaxy is small, but because it is enough. There is also a humility in this realization. We are not entitled to permanence. The Milky Way will not preserve us forever. Our planet will not last forever. Even stars are temporary. Everything changes. Everything ends. But humility does not negate responsibility. On the contrary, it sharpens it. Because if conscious experience is rare, then it matters how it is treated. If awareness is a fragile outcome of cosmic evolution, then preserving it becomes meaningful. Not because the universe demands it, but because the universe does not care one way or the other. Meaning, then, is not given. It is chosen. The Milky Way will continue its journey whether we exist or not. It will merge, evolve, and eventually fade. The universe will expand, structures will dissolve, and entropy will increase. But right now, in this moment, there is a small region of space where the universe is being observed, understood, and contemplated. That region is here. Not because it is large. Not because it is central. Not because it is eternal. But because it is conscious. And that may be the most remarkable scale of all. If we stay with that idea a little longer, something subtle begins to change. The universe stops feeling like a backdrop and starts feeling like a process, one that includes us, not as spectators, but as participants. The Milky Way is not a container that simply holds us. It is part of the same unfolding story. The atoms in your body were once part of interstellar clouds. Those clouds were shaped by ancient supernovae. Those supernovae were the deaths of stars that formed in earlier galaxies. In earlier eras of the universe. There is no clear boundary between you and the cosmos. The separation is conceptual, not physical. From that perspective, asking whether we are insignificant becomes the wrong question. Insignificant compared to what? Compared to mass. Then thoughts are insignificant. Compared to size. Then time is insignificant. Compared to duration. Then moments are insignificant. Yet moments are where life happens. The universe measures in billions of years and billions of light years, but experience does not. Experience happens now. Always now. No matter how vast the universe is, it can only ever be encountered one moment at a time. And that moment always occurs within a conscious frame. This reframes scale entirely. The universe is large. But it is experienced locally. No being, no civilization, no intelligence ever experiences the universe all at once. Every perspective is small. Every viewpoint is partial. That is not a flaw. It is the only way experience can exist. The Milky Way, then, is not a failure of scale. It is the scale at which experience became possible for us. There is also a quiet lesson here about expectations. Humans evolved on a small planet, under a small sky, surrounded by immediate concerns. Our intuitions about importance are shaped by survival, not cosmology. When we encounter cosmic scale, those intuitions break. We expect importance to scale with size, because on Earth it often does. But the universe does not follow human intuition. In the universe, the largest things are often the simplest. Vast clouds of hydrogen. Endless voids. Smooth backgrounds of radiation. Complexity tends to emerge in smaller, more constrained systems, where energy flows can be organized rather than dissipated. Stars are smaller than galaxies, but far more complex. Planets are smaller than stars, but more intricate. Life is smaller still, yet more complex again. Consciousness occupies almost no space at all, yet it carries the richest structure we know. So when we say the Milky Way is small compared to the universe, we are not saying it is unimportant. We are saying it exists at a scale where complexity has room to arise without being erased. This has implications for how we think about purpose. The universe does not appear to be built for something. It has no visible goal. It expands, cools, and evolves according to simple rules. And yet, from those rules emerge stars, chemistry, life, and thought. Purpose is not embedded in the universe as an instruction. It emerges as a consequence. That means purpose is not something we discover written in the stars. It is something we create in response to them. The Milky Way does not tell us why we exist. It gives us the conditions under which the question can be asked. And perhaps that is enough. There is a temptation, when faced with cosmic scale, to retreat into nihilism. To say that because nothing lasts forever, nothing matters. But this confuses permanence with value. A song does not lose its beauty because it ends. A life does not lose its meaning because it is finite. If anything, impermanence sharpens meaning. It demands attention. It demands care. The Milky Way will change. One day, its spiral arms will fade. Star formation will slow, then stop. The galaxy will grow red and quiet. Long after that, even stars themselves will burn out. The night sky will darken. But the fact that this moment is temporary is precisely why it matters that it exists at all. Right now, the Milky Way is alive with light. New stars are forming. Planets are circling. Somewhere within it, countless minds, human and perhaps others, are looking outward. Asking similar questions, each from their own small corner of the galaxy. These minds will never see the universe whole. But together, across time, they form a distributed awareness, a slow, collective attempt by the universe to understand itself. Even our science reflects this. No single experiment explains everything. No single theory captures the whole. Understanding accumulates. Piece by piece, observation by observation, across generations. Knowledge, like galaxies, grows through connection. In that sense, the Milky Way is not just a structure of stars. It is a structure of possibility. A region of spacetime where complexity has not only arisen, but has begun to reflect on its own origins. This leads to a quiet but profound responsibility. If meaning is not guaranteed, then it is fragile. If awareness is rare, then it is valuable. If this moment is temporary, then it is worth protecting. Not because the universe demands it. Not because we are central. But because we are here. The Milky Way does not need us. The universe will continue without us. But the universe that includes awareness is richer than the one without it. And for a brief time, in one ordinary spiral galaxy, that awareness exists. When we continue stretching this reflection, the story becomes less about where we are in the universe and more about how we inhabit it. The Milky Way does not rush. It rotates once every 200 to 250 million years. Since the first complex life appeared on Earth, our galaxy has completed only a handful of rotations. Civilizations rise and fall faster than a single galactic season. Even species are brief phenomena compared to the slow movement of stars around the galactic center. This contrast between cosmic slowness and human urgency is striking. We live fast lives in a slow universe. We worry about days, years, decades, while galaxies evolve over eons. Yet both tempos coexist. Neither is more real than the other. They simply operate on different scales. From the perspective of the Milky Way, humanity is a momentary fluctuation. From our perspective, the Milky Way is eternal. Both perspectives are valid. Meaning is always relative to the scale of the observer. This relativity of meaning is essential to understanding existence. The universe does not collapse all viewpoints into one ultimate perspective. There is no final vantage point from which everything is judged. There are only local frames of reference, each internally coherent. This means your experience is not diminished by the existence of larger structures. It is simply framed differently. When you feel wonder, fear, curiosity, or connection while thinking about the universe, those experiences are not illusions created by ignorance. They are real phenomena occurring in a physical system capable of producing them. They are as much a part of the universe as stars and galaxies. In fact, they may be among the rarest outcomes of cosmic evolution. The Milky Way contains vast regions where nothing thinks, nothing reflects, nothing asks questions. Entire spiral arms may pass without producing a single conscious observer. Billions of stars may live and die without ever being noticed by anything capable of noticing. And yet, in one small region of this galaxy, Awareness exists long enough to study the galaxy itself. That feedback loop is extraordinary. The galaxy creates the conditions for life. Life creates the conditions for thought. Thought turns back and examines the galaxy. The universe bends inward, studying itself through fragile biological instruments. This is not poetic metaphor. It is literal. Telescopes are made of atoms formed in stars. Eyes evolved under the light of those same stars. Minds interpret signals that traveled millions or billions of years through space before reaching them. The observer and the observed are inseparable. Once you see this, the idea of insignificance loses its grip. Insignificance assumes an external judge. It assumes something outside the universe assigning value. But there is nothing outside. Value arises internally, through experience and relation. The Milky Way is not important because it is large. It is important because within it, relationships exist, between stars and planets, between chemistry and biology, between perception and understanding. This also reframes loneliness. When people look at the vastness of space, they often feel isolated. The distances are too great. The silence too deep. But silence does not imply absence. It implies separation. And separation is not the same as emptiness. The universe is full of structure, motion, and interaction. It simply operates on scales that do not cater to our senses. Radio waves, neutrinos, gravitational waves, all pass through Earth constantly, carrying information from distant cosmic events. The universe is not quiet. We are simply tuned to a narrow band. The Milky Way hums with activity. Stars orbit. Gas clouds collapse. Supernovae erupt. Black holes feed. None of this announces itself loudly to human senses, but it is constant. We are not alone in a dead universe. We are embedded in a dynamic one. This matters because it shifts the emotional tone of cosmic reflection. Awe does not have to lead to despair. Vastness does not have to imply meaninglessness. Distance does not have to imply indifference. The universe is not indifferent in a moral sense. It is non-moral. It does not care, but it also does not oppose. It allows. And in that allowance, meaning emerges. The Milky Way allowed conditions for complexity to arise. It did not plan it. It did not aim for it. But it made it possible. That possibility is precious precisely because it is not guaranteed. This leads to another subtle point, fragility. Everything meaningful we know exists on the edge of stability. Stars balance gravity and pressure. Planets balance heat and chemistry. Life balances order and entropy. Consciousness balances structure and chaos. Too much stability, and nothing changes. Too much chaos, and nothing persists. The Milky Way sits in a delicate range of parameters. Its mass, rotation, chemical history, and environment all fall within a window that allows long-lived stars, heavy elements, and stable planetary systems. Shift those parameters slightly, and the galaxy becomes hostile. Too active, and radiation dominates. Too quiet, and star formation ceases early. Too dense, and gravitational encounters destabilize orbits. Too sparse, and elements remain primitive. We often talk about Earth as finely tuned for life. But the same is true of the galaxy itself. This does not imply design. It implies selection. Countless galaxies exist. Most may be unsuitable for life as we know it. We find ourselves in one that is, because only such places can be observed by beings like us. This realization does not make our existence inevitable. It makes it contingent. And contingency is another source of meaning. Things that could have been otherwise carry weight. Things that did not have to happen, but did, feel significant. The Milky Way did not have to form this way. Earth did not have to exist. Life did not have to arise. Consciousness did not have to reflect on the universe. Yet here we are. The scale of the universe does not erase this improbability. It amplifies it. Because in a universe so large, with so many possible histories, the fact that one of those histories includes awareness is remarkable. The Milky Way is not a cosmic accident in a dismissive sense. It is a successful outcome of physical laws operating over immense spans of time. And within it, life is another layer of success, not in purpose, but in persistence. We are not the goal of the universe. But we are one of its achievements. This distinction matters. Goals imply intention. Achievements imply consequence. The universe did not aim for us, but it produced us. And producing something capable of reflection is not trivial. As we continue to sit with this thought, the universe begins to feel less alien. Not smaller, but more continuous with us. The stars are not distant objects. They are earlier chapters. The galaxy is not a backdrop. It is a process. The universe is not a place. It is an unfolding. And we are inside that unfolding, not looking at it from outside. If we slow the pace even more, the universe begins to feel less like an object to be explained and more like a space to be inhabited. Imagine sitting beneath the Milky Way on a clear night. Far from city lights. The band of light overhead is not a symbol or a metaphor. It is a direct view into the disk of our galaxy, where billions of stars overlap along your line of sight. Each point of light is a sun. Many have planets. Some may have worlds with oceans, atmospheres, and skies of their own. And yet, from where you sit, all of that collapses into a soft glow. This is a quiet lesson in scale. Immense complexity can appear simple from a distance. What feels overwhelming up close becomes gentle when viewed as a whole. The universe is not shouting its vastness. It is whispering it. The Milky Way does not dominate the night sky. It blends into it. It invites patience. You have to let your eyes adjust. You have to wait. Only then does its structure reveal itself. The same is true of understanding. Cosmic meaning is not something you grasp instantly. It emerges slowly, through repeated exposure and reflection. This slowness is important. We live in a culture that values speed, fast answers, immediate clarity, instant certainty. But the universe does not operate that way. It unfolds gradually. Its truths are layered. You don't arrive at them by force, but by lingering. The Milky Way has been there every night of human history. Long before anyone knew what it was. People told stories about it, imagined paths of gods, rivers of souls, bridges between worlds. They were wrong in the details, but not in spirit. They recognized that this structure mattered, even if they didn't know why. Today, we know more. We understand stars, galaxies, expansion, dark matter. But knowledge does not replace wonder. It deepens it. Knowing that the Milky Way contains hundreds of billions of stars does not drain its beauty. It intensifies it. Because now, when you look up, you are not just seeing light. You are seeing time. Some of that light left its stars before humans existed. Some before Earth formed. Some before the Milky Way had its current shape. The sky is a layered record of history, compressed into a single moment of perception. That compression is astonishing. The universe gives us access to deep time without requiring us to leave the present. You stand still, and billions of years flow into your eyes. No other experience on Earth offers that. This creates a strange intimacy with the cosmos. The distances are enormous, but the connection is direct. Photons that travel for thousands or millions of years end their journey in your retina. In that moment, the universe and your nervous system intersect. Scale collapses. This is another reason why insignificance is the wrong frame. Insignificance implies separation. But the universe is not separate from us. It touches us constantly, through light, gravity, radiation, and matter. Even gravity from the Milky Way itself shapes your existence. The galaxy's mass determines the motion of the Sun, which determines the stability of Earth's orbit, which determines climate, which determines life. Galactic scale structures ripple down into everyday experience. The large is present in the small. This also works in reverse. Small actions can echo outward. A thought leads to a decision. A decision leads to change. Change accumulates. The universe does not care about these ripples. But they exist nonetheless. Causality does not scale away. When we think about the future of the Milky Way, we often imagine grand events, mergers, collisions, fading stars. But the future is also made of countless small processes continuing quietly. Stars forming in hidden clouds. Planets assembling grain by grain. Chemistry unfolding in cold darkness. Life, if it exists elsewhere in the galaxy, will not experience galactic evolution as a spectacle. It will experience it as background. Just as we do. This suggests something subtle but important: meaning does not require awareness of the whole. No being in the universe experiences cosmic history in its entirety. Yet meaning still arises locally. You do not need to comprehend the entire Milky Way for your existence to matter. You only need to exist where meaning can form. There is also a moral dimension to this, though the universe itself is indifferent. If awareness is rare and local, then each instance of it is valuable by default. Not because it is eternal, but because it is fleeting. This does not mean the universe cares if we survive. It means we might care, and that caring itself is meaningful. The Milky Way will continue long after humans are gone. But the Milky Way with humans in it is different from the Milky Way without them. Not in mass or luminosity, but in experience. Experience changes the universe, not physically in a large-scale sense, but phenomenologically. A universe that is experienced is different from one that is not. This idea is uncomfortable for some. It feels self-centered. But it is not claiming centrality. It is acknowledging presence. There is no contradiction between being small and being significant. A note in a symphony is brief and quiet, but without it, the music is different. Human existence is a brief note in the Milky Way's long song. Remove it, and the song continues, but something is missing. This is not a claim of cosmic entitlement. It is a recognition of participation. As we continue to slow down, the universe begins to feel less hostile, less indifferent, and more like a context within which fragile things can briefly flourish. The Milky Way is not a monument. It is a habitat. A habitat not designed for us, but capable of hosting us. And that capability is extraordinary. As we come to the end of this long journey, it's worth letting the universe stop expanding for a moment, not in reality, but in our attention. After traveling across galaxies, superclusters, and cosmic time, we return to something simple: the fact that we are here, thinking about it at all. The Milky Way does not ask to be understood. It does not announce its size or justify its existence. It simply is. A slow, ancient structure of stars and dust, rotating quietly in the darkness. For billions of years before humans existed, it turned without witnesses. For billions of years after we are gone, it will continue to turn. And yet, for this brief interval, it is being seen. Not all at once. Not completely. But enough. Enough to know that we live in a universe far larger than our instincts prepared us for. Enough to know that our galaxy, once thought to be everything, is only a small part of something vastly greater. Enough to know that size does not dictate meaning, and permanence does not define value. The Milky Way is not the center of the universe. Neither are we. There is no center in that sense. The universe expands everywhere, without preference. And somehow, that lack of preference creates room for countless different stories to exist side by side. Ours is one of them. We are the product of cosmic processes that had no intention, yet produced intention. No purpose, yet produced beings who ask about purpose. No awareness, yet produced awareness. That is not a contradiction. It is an emergence. When you look up at the night sky and see the faint arc of the Milky Way, you are not looking at something distant in the way a mountain or an ocean is distant. You are looking at your extended environment. The larger structure that made your existence possible. The context from which your atoms came, and within which your thoughts now occur. You are not standing outside the universe, observing it like an object. You are inside it, reflecting on itself. The scale of the universe does not diminish that reflection. It gives it depth. Yes, the Milky Way is small compared to the cosmic web. Yes, the cosmic web is small compared to the observable universe. Yes, the observable universe may be small compared to what lies beyond. But at every level, meaning arises locally. A galaxy does not need to be the largest to be home. A moment does not need to last forever to be real. A life does not need cosmic importance to be meaningful. It only needs to be lived. One day, the night sky will change. Distant galaxies will fade. Stars will go out. The universe will grow colder and quieter. The era we live in, rich with light and structure, is temporary. But impermanence does not erase significance. It creates it. Right now, the Milky Way is filled with light. Stars are forming. Planets are orbiting. Somewhere within this vast spiral, awareness exists, fragile, temporary, and profoundly rare. For a brief time, the universe is not just expanding. It is being understood. And that understanding, however incomplete, is enough. Because in a universe this vast, the fact that anything can pause, look outward, and ask what it all means is not small at all. It is extraordinary.